So let's start using this idea of the casserole and how it works. I got a great example for you. It says the point -4 minus 10 lies on the terminal arm of an angle in standard position. Yeah. Don't worry. I'll teach you. Watch. -4 minus 10 would be -1, 2, 3, 4. There's -4. -10 would be down this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right at the bottom here. So if you kind of connect them up, there's where your point is. There's -4, -10. Okay, there it is, right there. There's your nice coordinate. Now, I'm telling you that this point lies on the angle in standard position. Okay, so what do I mean? Here is our angle, boom. It's pointing right to -4, -10, and in standard position means it goes all the way around here. That's what we're after. Now, it says here, find the exact value. Take your calculator, throw it out, you don't need it. If it's the exact value, yes, you're going to probably have roots and all kinds of crazy things in it. But of sine theta, cos theta, and tan theta. How do you do this? One of the things that you have to remember is you have to always use the reference angle. And remember, the reference angle is always with the x-axis. Never forget that, all right? So there's my reference angle right here. So let's clean this up a little bit so I don't get confused with the standard angle, right? The standard position angle and the reference angle. Okay, so reference angle, this guy right down here. That's what we're after. Okay, look what we have. If that angle is part of a triangle, right? There's your standard. There it is, standard position angle. That's what we're after. Think about this. What was this length? It was -4. What was this length here? Well, that's -10. I wonder, what is the hypotenuse? Well, that's easy. All you got to use is a squared plus b squared equals c squared. You're after c squared. So, okay, let's do it. A squared. Well, that's going to be -4 squared. B squared, that's going to be -10 squared, equaling to c squared. Let's keep on going here. 4 squared is going to be 16, plus -10 squared is going to be 100. So add them together, you're going to get 116 c squared, okay? Square rooted, c works out to be the square root of 116. Now I'm wondering if we can reduce 116. Let's try. The square root of 116, reduce that. Doesn't that be 2 times 58 for that? Wouldn't that be 2 times 29? Aha! There's your pair. So as a matter of fact, this is 2 root 29. Do you remember how to do that? You might want to go back to the radicals unit and check that out. So your hypotenuse is 2 root 29. Let's get rid of all of this stuff and let's clean it up now. Let's see what we can do. Hold on. Okay, here we go. Clean that all up. Gone. Okay, that hypotenuse is 2 root 29. Now, think about this for a second. What is this asking you? It's asking you for the sine, the cosine, and the tangent ratios of that angle. Well, remember one thing. Add sugar to coffee. Now, if you remember, tangent's going to be the only positive one. Sine and cosine are going to be both negative. But think about what sine is. Sine of the angle, which is the theta. Now, if you include the negatives, that's now talking about this angle. Perfect. That's fine. Let's go. Include the negatives. Sine of theta, which would be, think about it, opposite over hypotenuse. So now you got -10 opposite over hypotenuse. 2 root 29, which is actually -5 over root 29, simplified. There you go. Aha! But it is now the cosine of this angle. The cosine is adjacent over hypotenuse. Adjacent being -4 over 2 root 29. Again, you can cancel this out to give you -2 over root 29. And guess what you got? Look at that. Beautiful. There's your cosine. And then finally, your tangent, which would be opposite over adjacent, would be -10 over -4, giving you, oh, look at that. The minuses cancel out, just as we predicted using the cast rule, that this in fact is positive, this is negative, and being that they have the square roots in every one of these, those are your exact values of sine, cosine, and tangent.